Parabolas is correct. Okie smoky dokey. Are you reading a bedtime story?
Yeah, that's exactly what I was read as a child. Math textbook, science information.
I know that's not true. You'd be better at math.
No, only the science information.
Oh, I see. I see. Okay, we need the right textbook. Look, it's Taylor. She's alive. You need to get your test back, don't you? I think this is you. There you go. Okay. Okay, math. We have today, Thursday, and then Tuesday, and then probably we'll do instruction on Thursday as well, and we'll wrap in the Conics stuff on the final. And then we will have 2 days, the following Tuesday and Thursday, of review for the final, and then we will have 2 days of a final.
So give or take 12 weeks.
Give or take 12 weeks? No. No. We don't have 12 weeks. We have 4 weeks.
Well, I said give or take, so you could take away.
Yeah, that's hilarious. Except it's not.
Yeah, it's not.
Okay, what did we do? 12 through 46?
14 through 32.
14 through 30. Oh, we did parabolas and circles?
Yes.
Okay, great. No, we're just trying to get through stuff. That's not torture. All right, 14 through 36.
32.
Yeah, that makes more sense. All right, we need some pictures and stuff, right?
For a bunch of them, yeah.
That means we need the TV to turn on.
This gives me time just to go to the right page. Because I didn't do that. You know that. I just didn't do it early.
Number 14. The equation is y equals quantity x minus 4 squared minus 3. The vertex is at 4, negative 3. Axis of symmetry is at x equals 4. It opens upward. And, excuse me, 16. The equation is y equals negative 6 times quantity x plus 3, quantity squared, plus 46. The vertex is at negative 3, 46. The axis of symmetry is at x equals negative 3, and it opens downward. 18 is x equals 1/3 times the quantity y minus 4.5, quantity squared, minus 2.75. It's got a vertex at negative 275, 4.5, axis of symmetry at y equals 4.5, and it opens to the right. Number 20 is over here. Number 20. Yeah, I can read. Number 20 is that one. '22 is these guys. Number 24 is this one.
My hair is too big.
That's crazy.
There's insufficient storage space, Sean.
26 is this one.
That was crazy.
28 is right there.
It's shortened.
Harumph. Number 30 is right somewhere. Keep going. Right there. 32 is y equals negative 1 over 200 x squared plus 50. Before I take questions, I'm going to get me some water. Because humans need water. Es muy importante. Well, we could, actually. That's true.
Yes. What you think?
Now they know it's there, so they'll be wondering.
What questions do you have?
16.
26.
16 and apparently 26. 16.
Well, 28.
My black marker go. Invisible. Ah, there it is. It's your fault you did it. That's crazy.
She actually did it to sabotage you. I'm sorry. She's not sorry.
Negative
She's lying to you.
squared minus 36x minus 8. We're supposed to find all the things. Or write it in standard form, identify the vertex, axis of symmetry, and the direction of opening. So what should we do?
Just factor out to x. Or 6, sorry.
Negative 6, right? Now what?
Now we complete the square. 6 divided by 2. Square. 3 squared is 9 plus 9 minus 50. Negative 54.
No.
9 times negative 6.
Negative 9
9
times negative 6 is 54. Did you find your mistake?
Where'd that negative 6 from then?
You have to, in order to take it off, you have to take it off times this, because it's going to be multiplied times this.
So you always put that funny, right?
No, I did not find my mistake.
Ah.
I still don't know how it's not that. Weren't you supposed to factor out the negative 6 from the 8 first?
No.
No? That's my mistake.
You move the negative 8 over.
So you move the negative 8 out, and then you defactorize.
Yeah.
Okay. That's yeah.
So the vertex is at negative 346. Axis of symmetry is at x equals -3. Direction of opening is down.
Why is there a test right there?
Because somebody needs to take it. All right. You did it again.
I didn't do it this time.
Did two. You hit it. Saw it happen. 26. Let's graph it. Now let's look at circles.
Yay. Circles are so fun.
Nah.
6 should be similar.
You know we did one exactly like 28 in class.
And it was too fast. Obviously, I did.
It was too fast. There's a recording! So don't even give me any of this too fast nonsense.
She was
26. We know that it has a focus at
Correct.
0, 4. It has a vertex at 0, 1. And we're supposed to write an equation and graph it. What is the direction of opening?
Wait.
Yeah, up.
Up. Yes. Up.
So we're starting with y equals a times x minus h squared plus k, right?
simple milk.
H is 0.
H is 0. H is definitely 0. We also know k is 1.
That's the vertex.
Great. Now we got to figure out A. So what formula-like constructions do we have for A?
We know the focus is k plus 1 over 4.
So the focus is H, K plus 1 over 4A. So K is 1 plus 1 over 4A equals 4.
Subtract 1.
Subtract 1 from both sides. We end up with 1 over 4A equals 3. Multiply both sides by 4A. We end up with 1 equals 12A. Divide by 12 on both sides, and we end up with A equals 1/12. So now we have everything for our equation. The answer to the first part is y equals 1/12 x squared plus 1.
Graph it.
And then you put dots on a graph and move on with your life, right?
Dots on the graph, draw a line.
What is the distance of the lattice rectum?
1 over 4a.
Absolute value. Absolute value of 1 over 4a, which we know equals 3. Equals 3. Half of that is 1/2. Right?
Why we have that? Because it goes from one.
Because that's the whole distance. Would count if we're going to count from the focus. We need half of it. And then we start shoving dots, connecting dots. So we put a dot at 0, 1. We put a dot at 0, 1, 2, 3, 4, which is not on our graph, but it helps us find some other things. So we go 1.5 to each side of that. 1 1/2 over here, 1 1/2 over here. And then we connect those three dots in a vaguely parabola shape. If it's not parabola, why parabola shaped?
Sean, it's actually a lot more like wide, lengthy wide.
Oh yeah, it should be real wide. So what's wrong?
I did math wrong.
Is this wrong? I think it is. Go back and look at your equation for this.
One over A.
1 over A, which is not 3.
12.
It's 12.
1/12. So that's 12.
But 6 and 6.
1 over A. A is 1 over, so 1 over 1/12. So that equals 12. Half of that is 6. That, yeah, because it's, that checks out. So you count over 6 and connect the dots.
Yeah.
Yeah. Okay, time is it?
Circle.
Look at circles.
Circular.
You got to find the vertex first on 28 by halving the distance between the directrix.
Why'd you say half like that?
We just did 26.
Oh, yeah.
Circles. And then depending on time, we might go back and look at 28. We shall see.
Ooh.
All right, what did we do here?
Right.
12 through 46.
12 through 46. Yeah, see, that's what I thought on that lesson.
And you were correct.
I was right.
Not on the previous lesson.
That's true enough. Number 12 from 9-3 is x minus 4 quantity squared plus y minus 9 quantity squared equals 36. Number 14 is x plus 7 quantity squared plus y plus 3 quantity squared equals 169. 16 is x minus 1 quantity squared plus y squared equals 15. 18 is x minus 5 quantity squared plus y minus 10 quantity squared equals 400. 20 is x minus 6 quantity squared plus y plus 3 quantity squared equals 25. 22 is x minus 4 quantity squared plus y plus 6 quantity squared equals 202. Number 24 is also an equation. That's crazy. We only graphed just a few things. Number 24 is x squared plus y plus 10 quantity squared equals 16. 26 is x plus 1 quantity squared plus y minus 6 quantity squared equals 29. 28 is x plus 1/2 quantity squared plus y plus 1 quantity squared equals 486 1/4. 30, we finally get to pictures. Or do we?
Wait, what was the answer?
Just kidding. 30 is x squared plus y squared equals 3,705,625. 20 was x minus 6 quantity squared plus y plus 3 quantity squared equals 25. 32 is the only one on this page, so I'm just going to hold it steady-ish. There's 32. It's all relative, I suppose. 30. Wow, that's beautiful. 34 is this guy.
A big blurry circle. Wow,
Why is it small?
that's pretty.
I don't like
Circle at a radius of 12, so I don't know that it's that small. 36 is this one.
He looks bigger, but he's actually smaller.
He has a rate. No, he's not.
Because the other one was in the 20s, wasn't it?
The other one had a radius of 12, didn't it?
Maybe.
It's got a radius. Oh, no, just kidding. It doesn't have a radius of 12. That's lies. It has a radius. Oh, no, it does. Yeah, square root of 144 is 12. Yes. No, that other one's got a radius of 16. Crazy people. Okay. 36 is that guy. 38 is this one.
Tiny.
It is actually tiny. 40 is this one. Has a radius of 5 and a center of negative 4, 3.
Kind of hard to read.
Yeah, it's impossible to read. It's off the screen. That's why I read it out loud to you. I'm so nice. 42 is this one. "44 is this one.
That's a really big circle. Or unless it's
It goes to the infinity. Oh, I certainly looks.
That's the next lesson.
haha. Why'd you go to the next lesson?
It's on. There's 46. And that's as far as we went, right? Or did we go to 48?
We went to 46.
46. All right. What questions on that one?
42.
We do one of the parentheses ones, like 24, 28, 26.
That's a useless question. That tells me you didn't do homework well. That's a question I cannot, will never answer. I cannot encourage such behavior, but I can do 42. Right? Isn't that what you said? Okay. 42 is x squared plus y squared minus 3x. Wait, yes, plus 8y equals 20. And we are expected to find the center and radius and then graph the thing. So what should we do? That is our goal, yes. So to do that, we should do what?
Have a little gap.
Yeah, so we're going to group the x ones, group the y ones. Complete the square twice. Now what?
Group or graph and do the
I thought you
square
changed it to the sign. Oh, it's in parentheses. I'm good. Thanks for the question.
Now what?
Graph it.
We need to answer the questions first, right?
Find the center. Where's the center? It's on -1.
What else? Square root that. Four times 38 would be 120 plus 32, 152, 153 fourths. So that's whatever that is. You have calculators, I think. About 6.2. And you start drawing dots
Yeah.
and make the dots in vaguely circle shape.
And then try to draw a circle and make a weird block.
Or what you can do is you use something round.
But if it's not the perfect size, it doesn't work.
But see, here is the secret. You ready? When you're doing your homework anyway. You draw all your circles the same size with the same template. And then you come back on and be like, where's the center?
-3 or
1/2, -4.
+4.
No,
No, it's -4.
-4.
Yeah, that's right. This
And then you go here, and you, let's see, it's 6,
Wow,
so
so bad at that. I know myself.
you do that, and then you just start like labeling it what you are saying it is. So the center is 1.5, -4 because I said so. This dot right here is at 7.5, -4 because I said so. And then actually it'd be at 7 point, not 5, but 8, no, 7. Because I said so. And you just label all that and then look, it's a circle that's perfect. It's great.
do you see those people that can draw perfect circles on the white?
Can't happen. It's not actually perfect. Not actually true. They can do it really well, which is so cool. Any other questions on this lesson?
No.
Yes.
Yes. What? What?
I was gonna say 24.
You were gonna say 24.
But then you decided against it?
And then you hold for a minute.
Sure. Do 24 real quick. They're too perfect. Has endpoints of a diameter at -4, -10, and +4, -10. So what's the radius? The radius is 4. That's true. These are the same, the y is at the same level, right? So the diameter is just between the x's. So the diameter is 8. Half of 8 is 4. Therefore, the radius is 4. What is 4 squared? 16. Why did I do all that math? What am I doing? What is in my head right now?
The equation.
The equation that equals r squared, right? So we can find r squared, and then we have one piece of our equation. We know that it's going to be equals 16 here at the end.
Yay.
All we need to know now is the vertex. What's the y part of the vertex on this one? Negative 10.
Thought it was a trick question.
It wasn't a trick question. So we know it's going to be y plus 10 over here. Right? We know it's a plus in the middle because this is a circle. So all we need to figure out is the x part. So it's going to be right in between negative 4 and 4. What's right in between negative 4 and 4? 0. So the vertex is at 0, negative 10. So x squared and then that mess. We didn't even have to use the distance formula or nothing. Or the midpoint formula.
That's how we solve all of the ones like that?
Yeah, if it gives it to you nice and straight and even, then yeah. If not, you got to start using midpoint formula and a whole bunch of other nonsense. Let's learn about ellipses, shall we? I said we might can, and I am now saying we currently can't. We still might be able to. Let's see how we do on ellipses. Because then Britain has less legs to stand on when it's next week, and she's like, it was so fast, but it won't be so fast because I started now. See, smart. Sometimes you have to Britain-proof your class.
Colonize it and then form a constitution.
Yeah, kick them out. Throw tea in their face. Oh wait, not that one.
No, throw tea in their water.
Throw tea in their water. An ellipse is like a circle. Actually, a circle is an ellipse. A circle is an ellipse with the foci shoved in the middle. Okay, here's some definitional things. Last year, all we did in this thing was we talked about ellipses, and then all they had to do on the test was label the parts. Y'all are going to get more than that this year. No, it's great.
How do I draw this good?
Well, so the way to draw it good is you put a nail at one focus and another nail at the other focus. You tie a string and then you go, and it's a beautiful ellipse. But we're not going to do that. So we're just going to YOLO some ellipses.
YOLOing is going horribly.
Well, that sounds like a you problem.
Is that a good ellipse?
All right, so you can have ellipses that are horizontal. And they look something like this, more or less. That's so cute. And you can have ellipses that are vertical, and that will look something like this. And it'll look something like this. And then, if you take pre-cal, you get the real exciting pleasure of taking an ellipse, or any of these shapes, and learning that no, you don't just have to have vertical or horizontal, but you can also rotate it. You start shoving a whole bunch of trig in it, and it's ugly.
Yeah, those just look
But
like
kind of
they
fun.
are when I try to draw an actual circle.
Right. Okay. So, standard form. Oh yeah, you also get a, no, we don't want to do that. We want to do that. We're not going to waste our time with that. We are going to do this. Standard form of this one looks like this. X minus h, quantity squared, over a squared, plus y minus k, quantity squared, over b squared, equals 1. Not r squared, not any other number, only 1.
Wow.
Okay? That's crazy. For the vertical version, It's very similar. Standard form. All right. Is y minus k quantity squared over a squared plus x minus h quantity squared over b squared equals 1. Okay. Now, really, the way to memorize this is the number under, whatever the number underneath x goes with the x direction. The number underneath y goes with the y direction. Okay? In this instance, a is going to be the bigger number than b. It stretches out more that way. If you try to keep try to keep track of which a goes under which one and whatever else, that's going to be a lot more confusing. The number that goes with the x is the one under the x. Okay? So don't worry about whether it's a or b. Worry about that one being under. Don't worry, it'll make sense when I get some examples. I see that face. Well, it might make more sense. Yes? Okay. So, ellipses have two foci. Which is the plural of focus. You're funny. And just like a parabola, in a parabola, the foci are how the ellipse is constructed. Now, I kind of very hurriedly explained how that works. If you take and put a thing in here, and you have a string that is a fixed distance, and you draw around the string, it'll always be equal from both focus. This just says. Okay, so that's what it is, right? So, to find the foci. In this one, it's going to, just kidding. I don't know that I like, that's fine. Okay, that's fine. To find the foci on this one, it's h plus or minus c. You're like, what's c? Don't worry, I'm going to tell you what's c. C is another constant that we get with a formula. Oh, I ripped it. Oh no, it's gone forever. It's okay, Jacob.
I think you did that on purpose.
I didn't. I was just trying to move it. I wasn't really trying to rip it.
Sure.
And K. Which makes sense. The H and the K are going to be related to the vertices, right? Now, how many vertices does an ellipse have? It has 2. How many co-vertices does it have? 2 as well. It's got vertices on the long axis and co-vertices on the short axis. To find the foci on this one, what would you do?
The same thing, but a little bit different.
Same thing, but what's going to be different? It's going to be K plus or minus C. The H is going to stay constant, and it's going to be K plus or minus C. To find the vertices, we do, which one is going to be constant on the vertices? Is it going to be the H or the K?
The K.
The K is going to be constant because it's on the same line as the center. So it's going to be H plus or minus A and K, right? So say the H is the one that goes with the A. It's just the one under the X, right? To find the co-vertices, what would you do?
The same for both of them.
The co-vertices are the short axis. So which one on the short axis is going to stay constant? The H this time. So it's going to be h, and it's going to be k plus or minus what? B. Oh, depression. All right? So you can figure these out, I suspect, with a little bit of thought.
We're a bunch of dummies. You need to explain it for us.
To find the vertices on a vertical one, the h is going to stay constant. And it's going to be k plus or minus a, because that's the one that goes with y. And to find the co-vertices, h plus or minus b and k.
Yippee.
So we need to know one more thing. What's the one more thing that we need to know? There isn't a directrix. There's one letter we don't know anything about how to find. We don't know how to find C, so we need to know how to find C.
I see. You see. But we need C.
Why don't they give that formula right here? It's C equals the square root of something. I think it's minus. Where is it? It's plus or minus, no, it's the square root of a squared minus b squared, I think. But let me make sure that I'm not lying.
Are A and B just any number?
Yeah, it's like the radius. Oh, it's right there. They just shoved it on a different page for random reasons. Oh, I see. That's dumb. I hate that. That's stupid. Yes, I was right. It is that. How are we doing? Pretty good. Let's do an example. Let's... That right there.
For both of them, it's that.
For both of them, it's that.
Look at this circle I drew.
Where would the center for both of them be?
In the middle.
Thanks.
At 0.
What would be the coordinates of it?
0, 0.
Not always.
The middle.
At H.
HK.
I was right.
No.
You are not. Okay.
But each case is the middle.
We want to do this example. We're going to find the coordinates of the center and the foci, the length of the major and minor axes of the ellipse with that equation. The equation is x squared plus 4y squared minus 2x plus 24y plus 21 equals 0. Okay. So, we need to get this in standard form, so what should we do? What?
Move the 21.
We do need to move the 21, unfortunately. We want it to be a 1 later, but it's going to have to be a 21 for now.
We rewrite it now. So we get
Yep. Now, we're going to do some complete the square, right? So x squared minus 2x plus 4y squared plus 24y equals negative 21. On the x one, we're good to go, right? We just start doing the green part, quote unquote, right? we do negative 2 divided by 2 squared, so negative 1 squared. So 1. So we add 1 here, and we can add 1 over here. Now, on the y, we have a problem, right? What do we need to do on the y one?
Get rid of that 4.
Get rid of that 4. What do we do to get rid of that 4? Factor it out. That's right. So I'm going to go ahead and factor this because I may as well. So this is going to factor into x minus 1 squared, right? This one we got to pull a 4 out. So plus 4, and y squared plus 6y with a space equals negative 20. All right, so now we do the green part again, right? So 6 divided by 2 squared.
That's just 9.
3 squared, which is 9. So we're going to add 9. Now, on this other side, we have to add 9 times 4, right?
Yes.
Wouldn't it be minus because it's in the parentheses?
No, because as we're doing it on the other side of the equals. We do the plus and minus on the parabola ones because we're keeping it on the same side. Does that make sense? But since we're doing it here and then doing it on the other side, then the signs just match.
That should be 21.
No, because negative 20 plus the 1. Yep. Okay. So now we're going to factor this, and we're going to do the math over there, right? So we've got x minus 1 squared plus 4 times x plus 3 squared equals negative 20 plus 36.
Is that supposed to be a y, not an x?
It is. Thank you. So then we've got x minus 1 equals 4, no, plus 4 times y plus 3 squared equals 16. Okay. Now, we know, not just because this is in the ellipse lesson, but we know that this is an ellipse and not a circle at this point. Why do we know that? What tells us that right now? Other than the fact that we're in the ellipse lesson. Because these are not the same number.
Should the 1 be squared? Yeah.
Yes. Like I was saying, because these are not the same number. Since these are not the same number, this is not a circle. And so since it's not a circle, we need this to be a 1. So how can we make this be a 1?
Divide by 16.
Divide by 16. Divide by 16 over here and divide by 16 over here. So on this first one, we've got x minus 1 squared over 16. This one, the 4 and the 16 reduce, right? To 1/4. So this is plus y plus 3 squared over 4. And that equals 1. So now it's an ellipse. So let's label some of our values. So what is h in this problem? H is 1. What is k in this problem?
Negative 3
Negative 3. Therefore, the center
is 1, 3. 1, negative 3.
is 1, negative 3. Now, what is a in this problem?
4.
It is 4 because it's the square root of 16. And what is b?
2.
It's 2 because it's the square root of 4. Right? Now, this ellipse, is it a horizontal one or a vertical one? It's horizontal. How do we know that? Because the number under the x is bigger than the number under the y. So this is a horizontal one, right? So we are asked to find the center. We did that. We are supposed to find the length of the major and minor axis. So in an ellipse, the major axis is this one. So that's the major axis. This is the minor axis. Right? So the length of the major one. So we need the vertices. So how do we find the vertices?
H plus or minus C.
H plus or minus C. So what do we need to find? So that's not the vertices, is it?
It's H plus or minus A.
H plus or minus A. You're talking about the foci.
That's right.
Yeah. So A we already found is 4. So one of the vertex would be 1 plus 4. Negative 3. The other one would be at 1 minus 4. Negative 3, right? 1 plus 4 is 5, so it.
The other one would be. Never mind.
1 minus 4 is negative 3. Negative 3. So how would we, from that information, tell the length of the major axis?
Subtract the distance between.
Find the
Or
distance.
find the distance between 5.
Between,
those
yeah,
points.
5 and negative 3.
Or just
What is the distance between 5 and negative 3?
8.
8. So the length of the major axis is 8. Let's do covertices. How do we find the covertices?
H, A plus or minus B.
Okay, so 1 and then negative 3 plus 2. So 1, negative 1. And then the other one is at 1, negative 3 minus 2. So 1, negative 5. So the length of the minor axis, how would we find that?
The distance from
Yeah, so the distance between negative 1 and negative 5. What's the distance between negative 1 and negative 5? 4. So let's pretend like the instructions also said to find the foci. So let's do that. So in order to find the foci, we have to find C. Square root of A squared, which is that, right?
That minus.
Minus square root, minus B squared, which is this. What's 16 minus 4?
That's 12.
12. So the square root of 12. Square root of 12 is approximately equal to what?
4 times the square root of 3.
Approximately equal to what?
2. Square root of 3.
It is 2 square root of 3, but it is approximately equal to 3.5. So to find the foci, what do we do?
The H plus or minus C.
So 1 plus 3.5, and then k is negative 3. And 1 minus 3.5, negative 3. So 4.5, negative 3. And negative 1.5, negative 3. So we went to graph the thing. What dots would we put on the graph? That was an easy question. When we go to graph the thing, what dots would we put on the graph? What dots would we put on the graph? We don't even need to put those on there, but we could.
The vertex.
Vertices, for sure. At the very least, these and these.
What's the difference between a vertex and a vertex?
Vertices is plural.
So there's multiple.
Right.
Yes.
So, vertices at 5, -3. 1, 2, 3, 4. 5, -1, 2, 3. And at -3, -3. What are vertices in an ellipse? Where are they? I'm asking you, Bluey. They're the vertices are the long ones, right? What are these ones called? The short ones. It's minor axis, co-vertices. So it has 2 vertices and 2 co-vertices. Okay. Those, and then the other ones are at 1, -1, and then 1, -5. And you connect those dots in a vaguely elliptical shape.
Beautiful. It looks more like an eye. It's too pointed and
Weird.
Homework is on page 620.
Bless you.
You're going to do numbers 12 through 32 evens.
This is so much work for one problem.
For the actual assignments, we're just going to have to find certain things for each thing, right?
What?
Never mind.
So on the assignments, you're going to have to write an equation given pictures. You're going to have to write an equation that satisfies conditions, and you're going to have to graph stuff.
Okay. But not all together in one problem.
No.
So it won't be as long as what we just did.
It's hot in here.
No, it's not. It's perfectly cool.
It's 73 degrees in here. Practically the sun.